Paperless documentation using electronic cage cards, an electronically supported rack, and an electronically supported changing station is changing the state of the art of workflows and the quality of recording transactions and documentation in animal rooms. Let me state a few essentials. The electronic cage cards cage talkers stay on the cage and update as soon as the data are entered into the animal management system. From the user's perspective, it is a seamless process with the AMS. The most efficient way to record data is where they are generated. The challenge is, to do this efficiently and fast, having hygienic contamination bridges under control while doing physical transaction with the cages and animals. This is the reason why we develop software and tools to do these updates as simple and as hygienic as possible in laminar flow stations and isolators. The third component I want to present in this cybernetic cycle is the rack. In this case, the DVC rack. It knows a lot about the situation in the cages, such as animal activity, and the need of food and water supply, and the need to change a cage by objective criteria. It is the component where cage changes in an animal room for whatever objectives start. Following the sentence of the great Aristotle, we have integrated those components to give you a maximum of performance.
Let us have a look at the live demo. Please think of the 3 cage talkers at the right bottom of this screen to be your cages on a workstation. Let's scan the second cage talker and create another cage card. The scanning of the label has to be implemented in the AMS. This code is a unique identifier of the label and is assigned to the internal cage in the AMS. We will now load a sample file to the web service with this client application instead of sending it as a string from the AMS. And after a while the cage talker will be updated. There is a possibility to switch between the 3 pages of the cage talkers using an infrared device. This is unique for the used label technology. Now we switch to the DVC rack and use some empty cages to link them to the cage talker, then containing the cage content originally transferred from the animal management system. After linking them, you can see the cage content also in the DVC. The cage talkers will be automatically updated with the cage position in the DVC rack. To do a cage change, the cage is pulled from the slot in the rack and brought to the changing station. We call those pulled cages also floating cages because in our cybernetic cycle they have not reached their destination, being for instance the changing station. We finally plan to do a mating. We also need an empty cage where the mating will take place. Therefore an empty cage talker has to be assigned to the empty cage on the fly, and that's the reason why we have to scan the cage talker in this little dialog and get the cage talker registered. The next step is to switch to the changing station. As we are using an integrated expert system, the transaction to be done with those animals is already identified and just needs to be confirmed by the user. If the transaction is not undone to correct a mistake, we now can create the cage talkers. Those few buttons can be pressed in parallel while doing the physical transactions with the animals. You can even follow the updates of the cage talkers while bringing the cages back to the rack. Pushing the cages back into their slots on the rack, which we also do on the simulator, we see how the cages appear again in the representation of the DVC rack. All changes on the workstation are updated in the DVC rack and the animal management system.
Conclusion: cage talkers, virtual changing station, and DVC rack are bridging and automating the documentation workflows between animal management systems, changing stations, and racks. They form an automated cybernetic cycle, including cage changes, cage inventory, and cage location control, thus saving hundreds of kilometers of walking distances and minimizing mismatches and other errors.